In this video, we'll be looking at how to prove this trigonometry identity 1 over cosecant x minus 1 minus 1 over cosecant x plus 1 equals to 2 tangent squared x. Proving of trigonometry identity is a very common question that is tested in the O-level additional math. So it's essential that you know how to do it. So let's try this question together. Alright, so this is the left hand side and this is the right hand side. So for this, we know that all the angles are in terms of x. So in other words, we will most likely not need to use your double angle formula. Okay, so now how would we combine this to form this? Well, if you take a look at this, right, you have cosecant x minus 1, cosecant x plus 1. When you look at this, most likely we will combine them into a single fraction. Alright, if you were to take a look at what we need to show on the left hand side, which is 1 over cosecant x minus 1 minus 1 over cosecant x plus 1, it's very likely that we need to combine these two fractions into a single fraction. So let's start off by doing that. Okay. So left hand side is equals to 1 over cosecant x minus 1 minus 1 over cosecant x plus 1. So now let's combine them into a single fraction. So I have cosecant x minus 1 times cosecant x plus 1. Okay, then on the numerator side here, I'll have cosecant x plus 1 minus cosecant x minus 1. Okay, so this is how you combine the fractions, right? So we multiply these two denominators together. So for this side, I will multiply top and bottom by cosecant x plus 1. Okay, and cosecant x plus 1. For this two, 1 over cosecant x plus 1, I'll multiply top and bottom by cosecant x minus 1 over cosecant x minus 1. So this is how I get it. So I'm not going to go through how to combine fractions. This should be, you should be quite familiar with it. So now let's simplify what we have now. So I have cosecant x plus 1 minus cosecant x minus 1 with a bracket in it. So if I were to expand it, I know that this will become minus cosecant x plus 1. Okay, so let me expand it first. Cosecant x plus 1 minus cosecant x plus 1 over. So next, I'm going to expand this, right? So this is like your a minus b, a plus b, right? Where a is cosecant x and b is 1. So whenever you have a minus b, a plus b, what do you get? You get a squared minus b squared, right? So, wait okay, so we know that basically your cosecant x is like the a here and your 1 is like the b here. So if I were to multiply these two together instead of expanding it one by one, I know that it is basically equals to a squared minus b squared, where a is cosecant x and b is 1. So if I were to simplify the denominator or expand the denominator, I'll get cosecant squared x minus 1 squared, which is 1. Okay, let me further simplify this. So now I know that cosecant x minus cosecant x, so I got rid of the cosecant x. 1 plus 1 is 2, so I have 2 here. Then I have cosecant squared x minus 1. Then I know that I need to change it to tangent square, right? So there is an identity in your formula booklet that says that so you know that tangent square x plus 1 is equals to secant square x. You also know that cotangent square x plus 1 is equals to cosecant square x. So now we have cosecant square x minus 1, right? So we know that it is equals to cotangent square x. So we will change this portion here, cosecant square x minus 1, into cotangent square x. Okay, next we know that 1 over tangent x is equals to cotangent x. Okay, similarly, 1 over cotangent x will also be equals to tangent x. So therefore, we know that this is basically equals to 2 tangent square x, which is what we need to prove on the right hand side. So we have proved it.